A particular fruit's weights are normally distributed with a mean of 370 grams and a standard deviation of 19 grams. The heaviest 5% of fruits weigh more than how many grams? So to figure this out, first off, I'm going to draw because we're normally distributed, I'm going to draw my normal bell curve here. And let me shade some area into the tail and suppose this is the 5% of the heaviest. Now the reason I am drawing on the right, that's a decimal point there, the reason I'm drawing this on the right is because we're talking about the 5% weigh more than, meaning these are the 5% of the heaviest fruits over here. So it's the more than. That tells me to shade on the right. Okay, but if that's the case, that means that we must have 95% to the left. And the reason I want to figure that out is because the table that we have tells us probabilities to the left, not to the right. So figure out how much is to the left, that's 95%, and now let me go get my normal distribution table and find the z-score. So I'm looking for 95% somewhere in the middle of the table where my probabilities or area are. So I'm looking for 0.95. I have 0.9495 and 0.9505. And so those sandwich 0.95 evenly. So I could either pick a z-score of 1.64, 1.65, or go in between them and pick 1.645. All of them should work. There's some tolerance for rounding. All right, so we're going to pick 1.645, right in between 1.64 and 1.65. Now, to convert this z-score into a fruit weight, I'm going to use our formula where we take the z-score that we just found, multiply that by the standard deviation, and add to the mean. So in our case, this will be 1.645 times 19 grams plus 370 grams. And that comes out to be about 401. And I'll throw on some decimals, but this is asking us to give the answer to the nearest gram, so let's round that and I get 401. Now, we could use a spreadsheet if we didn't want to use the table to get the z-score. And so a couple of different things we could do with the spreadsheet. Bring my spreadsheet up here. We could use the norm.s.inverse function, INV, and just plug in that probability to the left. And that'll give us a more precise z-score. So we used 1.645. I could use a more precise z-score, but it's really not going to change things that much. The other thing we could do, if we didn't want to have to deal with this conversion back into a fruit weight, is instead of the norm.s.inv, we could use the norm.inv. The S stands for standard, so it's going to give you a z-score. But without that, if you provide, first of all, the area to the left, then give it the mean, so in our case that's 370, and the standard deviation, it's going to do the conversion into fruit weights for you. So it gives me 401.25, round that, and again, you got 401.